Okay, proving identities. The first thing we need to remember are all our identities. So we have reciprocal, identities. So that was cosecant of theta equals 1 over I'm waiting. 1 over what?
What?
Cosecant equals 1 over what? Sine.
Tangent.
So then that means sine equals 1 over probably cosecant. And secant is
1 over cosine.
1 over cosine. So cosine is 1 over secant.
Maybe. Just maybe.
And then cotangent, 1 over tangent. And tangent, 1 over cotangent. The ratio identities. Tangent of theta equals what function over what function?
What?
Tangent is what function over what function?
Sine over cosine.
Sine over cosine. And cotangent is
Cosine over sine.
cosine over sine. And the last 3 are the Pythagorean. Cosine squared plus sine squared equals
Oh, that's gonna be the final.
1. Remember that now? Now remember, I can rearrange this. So cosine would be 1 minus sine squared. If I cosine squared would equal 1 minus sine squared. If I just wanted cosine, I'd take the square roots of both sides. So I can do all that rearranging with that. This chart is on page 257. If you guys want to look at it more, but it is there. Okay. Then 1 plus tangent of theta equals secant of theta. And these are squared. I'm not saying the squared, and I should. And 1 plus cotangent of theta equals cosecant of theta. Now, the way you remember, do you guys remember taking cosine squared plus sine squared minus 1? We divide it. Well, we took x squared plus y squared equals r squared, and we divided by x squared. We divided by y squared. Okay. So in the denominator of tangent is cosine. What is in the denominator of secant? Cosine. So that's how you can remember which one goes with which one. So with these basic trig identities, you're going to prove others. You can we'll have an equal sign. So you can make the right side look like the left or the left side look like the right. If they get really, really, really hard, you can make both sides look like each other. You can work on both sides, but none of the ones you do, you will work on both sides. It will be a left or a right. It won't be both sides. So this right here are your tools you get to use. And we did some proving before. We're just going to really focus on it now. So I have the sine of theta, cotangent of theta equals cosine of theta. On page 258 are a list of things that might be helpful. And one of those is, it says, look at the most complicated side. Left or right, it doesn't matter. When we had proofs the first time, they said make the left look like the right. Okay, well, I'm not going to tell you that. You get to pick. So, which side looks more complicated, the left or the right?
Left.
The left. The left has more things I can do, yes? So if I want to get it to cosine, I probably should start making things into sines and cosines and see if I can reduce, right? So sine is sine. I'm not switching it to cosecant, are you? No. What about cotangent?
You can switch it to cosine over sine.
So I have sine equals cosine over sine. Now you notice that I didn't put the theta in the second step. I don't care as long as it's in the first step and it's in the last step. I don't care if you put the thetas or the x's in between. If you are not changing the right-hand side, you don't need to write anything. You notice my equal signs are pretty much lined up. So should yours. Okay, we're not showing work on here. We're big kids. We're just going to show the result. So what would happen when I take sine times cosine over sine?
Cosine.
I would have cosine. So cosine theta equals cosine theta. And you put your little box. Mm-hmm.
I don't think a single one of us was box last time I did this.
You will lose a half a point every problem if you don't put a box. You will lose a half a point if they're not lined up.
So at the beginning of the test, put a box.
Well, you don't know where your end is.
On every single one.
Okay. Tangent of x plus cosine of x equals sine of x times secant of x plus cotangent of x. One of my things I will always tell you is make sure you wrote it correctly before you start working on the problem. Because if you didn't write it correctly, odds are you are never going to get the left to look like the right or the right to look like the left. Just like when we did Gauss-Jordan elimination. If you forgot a negative, the world turned upside down. It was already upside down.
Once we started.
Some big things is people will drop this and make it multiplication and not addition. Stuff like that. Okay, so left or right? Which one do you want to look at?
Far right.
Probably the right. Okay, the right looks like it's more complicated, yes? Okay, so I want to end with two things. Always keep your eye on the prize. What would you like to do with this over here?
You could turn cotangent into cosine over sine again.
Okay, so if you're going to do that, you might as well make secant what?
1 over cosine.
Okay. And I will continue to say, what do you want to do? Because there are probably 4 to 5 ways to do most problems after you get the complicated ones going. And you have to show me. You can't just put an answer.
Reduce the two across from each other.
Well, this is addition. I can't do that.
Oh. You're right.
Can you multiply by the reciprocal? Can you do that?
No, because, and the reason why you can't do that is because there's not a denominator to do that. And if I multiplied by the reciprocal on the left, I'd have to go to the right. And we're not solving, we're simplifying.
Okay.
So this is here, but we can't touch it. We can't move. We can't add or subtract. We're not solving it. Everyone understand the difference between solving and simplifying?
Yes.
Okay. So whatever we do over here is fine, but we can't cross that imaginary Grand Canyon. Okay, guys, again, we want two things.
Get common denominators.
We could. You guys want to get common denominators?
Or we could
Can we just add
No, because we can't cross here. Okay, we want two things, and we have.
He's talking about the.
Oh, you wanted to add these?
Wouldn't cosine over a sine or?
I think you're using the wrong word. We want to do that. You're saying add, but not add. What is that?
Factor? I don't know.
Distribute. You're wanting your kips and add.
Wait a minute.
Okay, that's why when I say what do you want to do, like describe it to me.
Yeah.
We need to distribute, don't we?
Yeah.
Because you're gonna start looking ahead. Because when I do this, I'm gonna get sine over cosine, which is what? Tangent. And over here, the sines are gonna reduce out, aren't they?
Yeah.
And we're gonna have what? Cosine. So we can't leave out a step. So we got sine over cosine plus cosine. So my final step is to make sine over cosine what? Tangent. And you must write both sides down and your box. Yep. So if you know your identities, is this going to make it this easier to do? Yes, definitely. And yes, if we did add those, Alex, we would have had to get common denominators, which you will have to do. We will have to multiply by the conjugate at some point. But again, conjugate would be a denominator and a numerator operation, not across the equal sign. So, okay. Cosine to the fourth of t minus sine to the fourth of t over cosine squared of t equals 1 minus tangent squared of t. So remember, this is like saying cosine of t to the fourth. We just write it this way. This is this. Left or right? Left or right looks more complicated. Left. Definitely the left. And if for some reason you guys want to work on the left and you want to make sure you can expand really good, you can switch these two sides. It's not going to change the problem. Okay. So, what do you think we could do with this?
Get the denominator out.
Can we reduce the denominator with the cosine for?
Well, but this is a quantity because we have the...
Oh.
You didn't put that.
I did too put that there. I didn't put parentheses, but if you need to put parentheses to stop you from doing that, then definitely do it. Okay. Aren't these difference of squares?
Yeah.
Yeah, so could I factor it?
Yeah.
Okay, so it would be cosine
I thought we were working on. Oh wait, never mind.
squared minus sine squared times cosine squared, bless you, plus sine squared. Over cosine squared. Now, do you have anything up there that looks like an identity now? cosine squared plus sine squared equals 1, doesn't it?
Mm-hmm.
Okay. So cosine squared minus sine squared times 1. Show that you're using the identity. Not by crossing out, by rewriting. Well, now that this is gone, yes. Well, I have one thing and I want how many? 2. Can I split this into 2 fractions?
Yeah.
Yeah.
Okay. See, I'm writing my equal sign first so it kind of stays lined up. So I can separate this into 2 fractions. So I'm going to have cosine squared over cosine squared minus sine squared over cosine squared. Are we getting close to what we want?
Yes.
What's cosine squared over cosine squared?
1.
1 minus
Tangent.
tangent squared.
Yeah.
So then 1 minus tangent squared. I have t. Now we got to put back our t's. And our box. Now, as you go through, you're going to be like, oh, the last time I saw that, I did this. If it doesn't work, try something else. But try something. Don't just sit and stare at them. Because if you guys don't get to the point where you're doing them on your own, it's just like with Gauss Jordan again. When you would come in, you're like, I didn't know what to do, so I didn't do anything. I'm like, that doesn't work. Because you have to try stuff and learn that it doesn't work to be able to figure out what does work. Okay, so then I have, I think this is the last one. Oh no, we got some more.
How many do we need to do?
Well, let me see. How far are you going today? 21? We'll probably stop after this one. Because yeah, we'll stop after this one. Then we'll pick up. Tomorrow we'll do some more examples. Unless you just want to do all examples today, but I think this marker's about had it. That was my point. 1 plus cosine of theta equals sine of theta divided by 1 minus cosine theta. If you guys want to use the blank paper, grab a bunch rather than your lines. I get caught up on trying to not use so many lines, but then my brain gets all squished. And if you can't tell the difference between one step and another step, your brain is going to be squishing things together and you're going to get all confused. So, yes, I know we always like to conserve paper. It's the end of the year, but I got plenty of scratch paper you're more than welcome to use. Okay, left or right side?
Left is easy.
Right.
Left looks easier.
Left looks easier, but which I don't have anywhere to go with that. Unless I put a square root in there.
No, left looks easier, so we should get the right.
Oh, okay. I was like, yeah, I really like the way the left looks, but there's nothing I could do.
Right.
Okay, so what could I do? I got to get everything with like a cosine, right?
Yeah.
So what identity gives me sine and cosine together? Square. Well, tangent, but I don't want to add in tangent.
No, Pythagorean.
Yep, the Pythagorean. Okay, so
Ew.
I could change this because I want cosine, yes. So what does sine squared equal with my Pythagorean?
The square root of 1 minus cos.
Well, I got squared. I don't want to put square root in there.
Well,
So sine squared
Cosine?
plus cosine squared equals 1. So if I solved that for sine squared, what would it equal?
1 minus cosine squared.
1 minus cosine squared, wouldn't it? Okay, so 1 minus cosine squared over 1 minus cosine.
Can't we reduce that?
Not unless we can reduce the whole thing, so that means we have to factor, yes? Can you factor the denominator?
No, you can factor 1 minus cosine out of the top. Did you?
What do you mean by that? What would the numerator does, I'm going to just try to use the right words. The numerator does factor. How does the numerator
It'd be
factor?
1 minus cosine and then cosine. Wouldn't it?
It'd be 1 minus cosine
And then 1 minus cosine. Plus cosine.
plus cosine. Difference of squares, right? I'm just reviewing that with my geometry. So, Olive, right now, you better put parentheses around every single quantity you have.
That's what I'm gonna do.
Because I can already tell, you'll be like marking everything off. And then showing me that, besides that. Okay, so now, now can I reduce?
Yeah, now we're done.
Now we're done. So then I have 1 plus cosine theta equals 1 plus cosine theta.
Wow.
Now, you notice I didn't cross things out. We're big kids. We should be able to go from here to here and tell people.
I love crossing them out.
Okay, this is what I'm going to tell you. If you want to do all that mess, you're going to do the problem twice.
Why?
Because I will take off for all that mess.
That's crazy.
Because the proof is nice and clean.
Second dash.
Yep. Got to do it in your brain. I'll see people like this. They'll have it like here and they'll go, like they'll have, so they can do that without having to rewrite the problem. I see it all the time.
I should do that.
And I'm okay with that. But this should be nice and clean.
Boring.
I know. Questions?
Is that it?
Okay, yep, that is it. You have 1 through 21 odd. If you struggle through one, try one of the evens because the odd evens are pretty similar in operations. Now, if you look at the back of the book, remember that there are different ways to do problems. So if it doesn't make sense what they're doing, doesn't mean that's the only way to do it. Back here on this problem, when you guys did this, some people could have distributed first. Yes, so.